For example 2, we're going to simplify this trig expression, which means we're going to use some different trig identities and factoring to help us out. What I noticed between these two terms is I have a common factor of sine x. So if I divide by sine x, I'm left with cosine squared x minus 1, because sine divided by sine is 1. There is a trig identity that has cosine squared in it, and it says that the sine squared plus the cosine squared is 1. That means that if I subtract 1, I get sine squared plus cosine squared minus 1 is 0. And if I subtract sine squared, I get cosine squared x minus 1 equals negative sine squared. So what that allows me to do is take out cosine squared x minus 1, and I'm going to put in negative sine squared. So it becomes sine x times negative sine squared x. And if I take sine times negative sine squared, I get negative sine to the third of x, and there's a simplified version of example 2. Try number 35, then see if you can figure it out, and then press pause, come back. Well, the first thing I notice is that I'm going to take sine, I'm going to change this to 1 over sine. So sine of theta times 1 over sine of theta minus sine of theta. If I do distributive property, sine times 1 over sine is just 1. Sine times sine is sine squared of theta. And I do have an identity that has sine squared in it, and that's the same one we used before. And it says that sine squared plus cosine squared equals 1. This says 1 minus sine squared. So by subtracting the sine squared, I get cosine squared equals 1 minus sine squared. Well, since I have 1 minus sine squared for both those, the answer is cosine squared of theta, like that.